In this demo, we're going to try and create this I-beam. So I'll just do the first one on the top row here, and I'll go to CATIA and just create an I-beam. Whoa. There we go. And then we'll flip this around. Why did I do that? I'm going to select this plane, roll to view. Okay. And we'll just create an I-beam real quick. Turn my grid on. Just do a simple example of an I-beam. It's way huge. Okay, now what I gotta do is break the line. So I'm gonna break this. Oh shoot. I didn't mean to do that. I'm gonna delete that line and then this one here, where those two lines overlaid each other from the end of this vertical rectangle. So now I have just this line and just this line, and then we'll take that line and we'll break that. So you just select on the line. I like to break it right in the middle. Whoops, I forgot to double click the break. Break it here, and the reason why I'm doing that is so I can go into the corner command and corner these lines. So I'll double click the corner. Alright, so simple, easy way to make an I-beam, but and then you can constrain the profile and then build it. But this is not what we're doing. I'm going to show you how to create a solid that has relational design implied so that we can publish product structure, publish elements into a product structure to link other elements to this. So for our example, we're going to build a mold fixture to create a composite I-beam. But I'm going to use numbers off a chart just as an example, so hopefully you can use this as a reference on how to go about doing your part for the class project for the mold fixture. So first thing you're going to be given is the coordinate system for the center axis of your I-beam. The example I have is a terrible picture because it's on its side. It looks weird, but basically I like this profile, but they didn't give me a Y value. Just got to make one up yourself. We're going to create a center point of this I-beam, and then we're going to create the profile right in the middle of the I-beam, and then we're going to extrude it in either direction. So I just tried to find something that had numbers that hopefully you guys can see here. Again, this is only an example. You're not going to do it exactly like I'm doing it. The technique will be the same, but all the values will be different. So I know A, this is weird to me because the I-beam is on its side. The height is A and the flange is B. So I know those. So what I'm going to do is create my height and my flange planes. But first I got to establish where the center axis is going to be. So I'm just going to make up coordinates for this example to make it easy. If you're creating an I-beam for like maybe you're going to put a bunch of I-beams up and then put in a floor like in a construction building, or doing a marine, maybe I don't know, ferry boat or a ship or something, even an aircraft, whatever it is you're building. This X here is your primary direction, and your Y is your secondary direction, and then your Z is your tertiary direction. All right, so when we go and create an axis, we're going to do an axis on a point. So in the geometrical set, we're going to create a point at a specific coordinate. So you'll be given a coordinate in the assignment. X is going in this direction on a ship. That's forward and aft. The X is forward and aft, front to back. Let's just, for argument's sake, just put in 10. And then you have your Y direction, which is the next one, the secondary. If you go positive Y, it's going to go this way. If you go negative, it's going to go this way. So we started going 10 inches in X, and I'm going to go back in the negative direction. This would be known as the left buttock line on an aircraft. So we're going to go left buttock line, so that means we got to use a negative number. So I'll just go negative 10, and then I'm going to go up in the waterline direction, or the positive Z direction, and we'll just go 5 inches up from there, just to make that simple. Okay. I could go way high if it were a ship or something. It's going to be a lot higher. But just as an example, if I go to 50 and hit enter, that axis is way up in no man's land. Okay, you have to say okay, and you'll see a point has been created with these coordinates, and an axis has been created, and that is known as your local axis. What I do immediately is I hide the absolute axis. So when I go to model our view, fit all in, it zooms right up on the axis, and it looks just like what you normally pull up a model. The absolute axis is just sitting there, okay? So we're going to build the I-beam so it goes in the positive negative direction in the Y. So we need a profile on the XZ plane. So what I need is to create a plane from here where Y equals 0, okay? So I'm going to go into model essentials. In part design, you do have a plane feature, so you don't have to switch to wireframe and surfacing. And I'm just going to go 0 inches, hit tab, select OK, and I'm going to right away rename this. BL stands for buttock line 0. LBL would be left buttock line, RBL would be right buttock line. So I know BL is right down the middle, okay, of either your aircraft or your ship, or just right down the middle of the axis. It's a 0 position where Y equals 0. Remember, Y equal 10 over in the negative 10 for our coordinate, and left buttock line negative 10. So Y0 is going to be right here at dead center. And then Y10 would be way over here, and that would be right buttock line. Okay, with that plane, I'm now going to create top and bottom. So I can minimize this, and what I would do immediately is rename this to the local axis. This is also known as the part axis. So on the I-beam, the height, because this is rotated wrong, the height would be up and down, would be 3 inches. So I'm going to go plane, select this plane, and go 1.5. And select OK. That plane represents the top of my I-beam. You might wonder, well, why did you go 1.5 and not 3? Because the next plane is going to be in the reverse direction, 1.5. That's what's going to give me my total of 3 inches. I'll select OK. Again, I'd recommend renaming these. So Z's at 50. What you can do is go to Properties and rename this to Waterline. And it's 50 plus the 1.5. So you got 51.5. I put in parentheses top of beam. Okay, just to help me remember what's what. So I recommend you guys name these things so you know what you're picking on later and why you're creating them. It doesn't take long to forget what it was you were doing. So this would be 48.5 for the bottom. And I'll just name that. That's the bottom of the beam. Now going in the X direction is the B value. Again, because this is rotated 90 degrees. We want to flip that negative counterclockwise. So we rotate it counterclockwise. B is the flange, and it's presumed that both flanges are the same. So it's 2.5. Okay. So under plane, from this profile, we're going to go 2.5 divided by 2. And I'll hit tab so you can see it's 1.25 on that direction. I'll select OK and grab plane and grab this plane here and reverse the direction. Okay. Whoops. So now I've created 2 planes. Those are the station planes going along the X direction. Properties. This one here is the forward station. That would be, we're at 10 in the X direction, and then the beam was 1.25. So this is 11.25. And I'm just going to put forward. Oh, sorry, that would be aft. And then rename this one. Remember, the closer you get to the front, the lower the number. 0 is in the very front, and anything bigger is going towards the aft or back end of your automobile or your ship, aircraft, whatever it is you're working with. Okay, so this one was at 10 inches and then got closer by more than an inch, so it's 8 something. So this is your station. What was it? 10 minus 1.25? I think it's 2.5. Hit tab. Oh, sorry. I can't do that. What am I thinking? It's 8.75. And then we'll put forward. So that's your forward plane. Alright, so again, I now have a plane so if I rotate this 90 degrees counterclockwise, this is the top flange, this is the bottom flange, so I created those are your water lines up and down. And then the forward, if I rotate this here, this is the forward and this is the aft flanges, okay, which was 1.25 from center. Now the thickness is 0.2, so I need to create a plane 0.2 to represent all the wall thicknesses. So I'm going to go to plane, select this plane, and oh geez, what was the number? 0.2. So it's 0.2 thick, and hit tab. So T1 is this web thickness here, and T2 is this thickness on either end, which is 0.2. So I'll select that one. Actually, let me choose the top plane, reverse the direction, go 0.02 and select OK. I'm doing that because I had the top, so I have this come off the top and then the next one will come off the bottom. Again, using that same feature, I go to plane, 0.2, select OK. Alright, so those two planes, which seems pretty thick. I must be doing a steel beam or something here. No, alloy. Okay. Now we're going to do the inside wall thickness. That's this thickness here. So that's again from your along your station cuts, and this one is only 0.13. So when I create a plane, I'm going to come off the YZ plane, 0.13 divided by 2, and hit tab. Select OK. Ooh, I see. I should have renamed some of these already, but I'm going to live dangerously here and get tight in here because there's planes are going to start getting really close to each other. I want to grab this YZ plane and reverse the direction. Then we'll select OK. So we're a 1/16 of an inch on either side. So I have all my planes in here. What I'll do is rename that. And I'll just use my up arrow, see if I can't find my water line. So this one says, see, I got top. You can change whatever that waterline thickness is, you know, subtract the 0.2 to 0.3, right? Do I have a point in there? Me, probably I would just change that to say thick. Standard THK will represent thick. So now you know that this, what? Oh. This thickness here came from down here, and then this one here, properties. I don't really like to even change that number to tell the people where I'm at. What I like to do is, oh God, waterline, bottom beam, thick. I'm telling the people, hey, from waterline 4850, this is the thickness of it. Okay, so I'm going to say that that's 5150, and I'm representing the thickness. So I can correlate which one's which. That's what I think is easiest. It really is company dependent on how they're going to have you do that. But if it were my company, that's what I would do. Just try and make it easy to trace back where it's coming from. So I know that these represent the thickness off of these two wall thicknesses. And then I wouldn't even name it a station waterline, okay? They don't all have to be called that. Usually your station waterline buttock lines are called off for the main part of it. On this one, what I would do is I would rename this forward that is the T1 thickness. So you could even reference that T1 thick. This one's in the back, so I just hit the up arrow and say aft T1 thick. Now I've got all the planes that represent this entire profile out here. Okay, I got the thicknesses, the bottom, the top, this thickness, the T1 thick. Okay, so the next step is to create the sketch profile. So what I'm going to do here is select right on the buttock line 0. Instead of trying to figure it out and find it in this mess, just grab it off the tree. That's why I recommend you name them. The only problem is when you grab it here, it won't let you just go into the sketch like you're accustomed to doing, where you can select on this plane here and then pick that sketch. So you got the wrong plane though. When you hit the buttock line, you can hit this, go to model. You have the sketch icon. Okay, and then all you have to do is hit this OK button and it switches you into the sketch. Now, the beauty of this is, for the previous exercise, we learned how to do all that intersections. We want to intersect all the planes we just created to the buttock line plane. So I highlight all of those first so I can see what all I've grabbed, and you're going to find the intersection 3D element. Okay, that's in the sketch tools, and the feature is called intersection 3D element. I'm going to grab that, and then I'm going to select near element. I'm going to use that buttock line plane here. So you can see in the pop-up window, the window moving, it's called the pop-up window. You got the elements to be intersected. I got all 8 of my planes. It's going to intersect to the buttock line 0. So I highlight this field here and select the buttock line 0 and select OK. And it creates all those lines. All right. So if I go to the corner command, you'll see that this is going to do that to me, where the line here goes away and then I can't corner that. Okay, so I'm going to hit undo to that, and I'm going to have the same problem when you go to the trim command. And I'm going to select the trim with the scissors, select the portion of the line you want to keep. I select this one and I select this one, select trim again, select this one and I select this one, and then what happens is the line here goes away and I don't have the line there to trim. Okay, because as soon as I trim that to that, it got it all the way down here, which is great for that end, but it doesn't give me a line here on the top to work with. So I'm going to hit undo twice. What I would do is I would break this line, I would break this line, and I would break this line, and I would break this line, so that I will have the ability to do my corners, okay, as well as trim these ends. So all we have to do under the trim command is the break command, and the option is that you select it first and then select where you want to break it. I just hit the F1 button. Oh, I get errors. Yeah. Supposedly it showed me how to do that. So what I'm going to do to not have to keep activating the break command is I'm going to double click it. I'm going to select this line, and I like to just break it right in the middle. That just seems to me the most sense. So it doesn't have to be perfect, honestly, but I just like to do it that way. So I'll select this line and I'll break it here in the middle. I'll select this line. I don't really even have a middle for this one, so I could just select a line and then click anywhere to break it. So wherever you click, that's where it's going to break it. You want to make sure you got that right. So when you put your cursor over these, you see how you can see that's a whole line, but this line here has been broken. It stops right here in the middle. This one's on that side, and same with this one. Oh, it looks like I didn't break that good. What happened there? Let me try to break this line again. I could have sworn I got in the middle here. I probably have 3 lines now. There's one, and there's one. So I don't know what I did wrong there, but What you want to do is try and break them in the middle. All right, and then what I would do once they're broken is you can use that trim command. And I just go around this selecting the parts I want to keep. Select on the line portions you want to keep. All right, maybe I should have zoomed up better on that so you could see. See how it's broken there? I'm going to select on the portions I want to keep. I'm going to even trim these here. You might be wondering, why would you trim it when you put the corner? That would automatically trim in it. You might feel like I'm making an extra step, and maybe I am, but I like to get all my corners in all at once. So if you create your I-beam like that, you can stop the trim, go to corner, and highlight this whole area right here, and then do them all at once. And I'll go back here. It says the radius is 0.25. So I'm going to do a radius of 0.25. Analysis. This profile is constrained. This profile has an isolated element, which, oh, see that line where I broke it wrong somewhere? No problem. I can just hit this delete geometry, and now I have that closed profile. Okay, I'll close that off. And there's your I-beam. Now I'm going to exit out, and there's the cross section of the I-beam. Remember, we're dead center, and we want to create the I-beam left to right. How long is the I-beam? We didn't get a width on this one. Or is I thought that was weight. I don't know what that is. Okay, maybe I'll just steal from here. So here's another website where you have 6061 aluminum beams, and what you do is you can find standard beams, and hopefully one of the beams that you need would work. If not, maybe you need one that's 2.9 inches instead of the 3. But the 2.8 is this next size down, which is too small. So you would have to buy this one and then trim it. All right, we're just going to, for simplicity, make this 4 inches. I'll go 5 inches. So we want to link that to left and right buttock lines, or you could say Y and Z if you're not doing a marine part, a maritime type environment or aircraft. It'd just be Y values. I'm going to demonstrate this using right buttock line, left buttock line. So we're going to go back to plane. Oh, God, what have I cancel here? I didn't even mean to have the sketch highlighted. Let's go back to plane. And we're going to pick buttock line 0. Remember, you want to use your buttock line 0. That's why we have that. So I'm going to use buttock line 0. I want everything to be related to buttock line 0. I'll go 2.5 inches. Preview. Do you know if that's right buttock line or left buttock line? I'm going to select OK. I'm going to move this sketch into the part body so that I can make a solid of it. Go to properties, RBL. Oh geez, what did I do? 2.5. Yeah. Okay. And then from the buttock line here, we're going to go plane, reverse that direction, select OK, and then rename that. I'll just use the up arrow real quick and change the R to an L for left buttock line. Now that we have the buttock lines, we know where it's going to start and finish. So we can go to pad, select sketch 1, and what we're going to use is, instead of default direction, or instead of type dimension, we're going to go to plane, and the arrow is going this direction, so we're going to go to that plane. And then to go the opposite direction, we're going to go to plane and select this plane over here, select OK, and that is how you create an I-beam. Alright, I hope this example helps. I think it'd be a good idea for you guys to do this part, actually do this part, so that you'll have the right concepts to do your part.